So this is going to be the briefing for the practical of lipid, qualitative and quantitative analysis. And I am Dr. Jaya. And this practical you will be covering into experiments that is broken down to be qualitative as well as quantitative determination on lipid. We will select two types of oil normally, and that will be olive oil as well as palm oil, and we will run through these experiments. The qualitative here refers to some sort of observation, and also can be said does not involve any values or numbers, while that of quantitative is involving calculation or determining values or numbers, such as seed value, which we will do later. And compared to previous years, you are lucky because managed to obtain a number of videos because at least in the last semester, things were unable to be done face to face, like what is being done in this semester. Therefore, had to go and get videos in YouTube or even build our own videos in facing the practical, since the students were not in the laboratory and in fact they are in their homes. But because of that, we have also included the videos, the links at least, for you to observe on how the practical is to be conducted. At least you watch it prior to coming to the lab. You will get a good idea on its principle and also hopefully practicality before you actually do a hands-on. So for qualitative, have here one video on the saponification reaction on preparation of soap, which you can say the first experiment that you are doing is actually making soap in other contexts. Okay, and then you have quantitative experiments or video links. There are a number of videos being selected. Here you have on the acid number or acid value, one video up to 5 minutes that looks into titration of oil with the use of potassium hydroxide put in the burette, and also calculation related to it, acid value. And then you have saponification value determination provided with one more video that consists of 3 minutes. Normally, I select videos which has a high number of views because in that is a way to gauge that they are good videos for you to watch as well. And then the third one is on the iodine value. Okay, so quite thorough in terms of you observing certain videos to have a prior picture or idea on what you plan to do in the lab itself. So I hope you actually view the videos before coming to the lab. And then this is on introduction or overview about lipid, uh, perhaps already covered in the lipid lecture on macromolecule. So this is like a reinforcement or revision. Let me just go through it as fast as possible. Basically, lipid has been categorized as non-soluble in water, and because of the hydrophobicity or non-polarity, they are all grouped as lipid. Few components make up lipid, then they are almost entirely non-soluble in water, and rather they are soluble in organic solvents, and given some examples there. Uh, and In terms of what are their components, they can be divided as triacylglycerol. You know what is triacylglycerol? TAG or TG, and it involves having the glycerol backbone attached with three fatty acids with different length and also unsaturation. You also have phospholipid, still having the glycerol backbone, having one or two fatty acid, with additionally attached with negatively charged phosphate, and also the X group could be serine or ethanol amine as an example. Then you have sphingolipid. Now you don't have the glycerol backbone, but you have instead the sphingosine as the backbone, and with also variation in the fatty acid attached to it. Okay? And steroids such as cholesterol, estrogen, testosterone comes under this group. To name a few, there are still more than that. Okay? And also been added there about conjugated types of lipid, and these are a bit difficult to be extracted, also difficult to be isolated away to be studied, so a bit more complex type of lipid. And then a bit on the functionality of lipid. Unlike protein, of course, lipid has very little functions. But in terms of what is its function, is as an energy reserve. And you know the fact is, it's a long storage of energy reserve where it can provide twice as much as energy compared to same amount of carbohydrate. Okay. Moving on, yeah, there's also in terms of the fatty acid or fatty acid linked to the triacylglyceride varies in terms of number of carbon and also saturation and unsaturation, and even some of the examples there. And we now move to the qualitative analysis, which later we go to the quantitative. Qualitative has the materials to be prepared. Normally, this kind of practical, which is long, should be done in two sittings or 3 hours, and then another 3 hours, part one, part two. That means in 2 weeks. The first week or the first 3 hours is actually to prepare these materials, and if time permits, then we can get into the experiment itself, but if unable to, we reserve it for the following week or any remainder to be done on the following week. So let's look at the materials to be prepared for the qualitative analysis. It involves the preparation of well, the vegetable oil as the samples, and normally we are very much happy to use commercial palm oil as well as olive oil as the sample to be determined on qualitative as well as quantitative. And we also have pure fatty acids. This we have to see whether it's available in the laboratory, whether we have managed to purchase it. If none or one only available, then that's what we're going to do. But normally, sufficient to just do the palm oil and olive oil. Okay? And fat solvent, it says here, equal volume of 95% ethanol and ethyl ether, but it's actually, when we buy the ethanol, it comes in 95% ethanol, so you can say it's one ratio of one of ethanol and diethyl ether. And so far, I think we never neutralize to phenolphthalein. We'll just accept it as it is in a neutral pH. uh, if you a bit worried, you can actually use a pH meter to determine whether it's neutral, and if it's not, then you can adjust it to 7. But so far, I can recall we did not do it. Okay. Potassium hydroxide, you need to prepare. As you can see, already given what need to be done, 5.6 gram in 1 liter. But how to prepare it is a different story. You must use a volumetric flask. And is it necessary to prepare 1 liter? Yeah, or is it sufficient to just take 5.6 milligram and prepare 1 ml? So, and then also how to properly prepare. Usually the use of volumetric flask is the best way to prepare. Okay, bear in mind all this. And then alcoholic potassium hydroxide, you can see potassium hydroxide, number 4 is in water, while alcoholic potassium hydroxide is using ethanol rather than water. And then I hope you are aware about what is the 10% weight over volume or volume over volume. That one should be, given information or some knowledge on what is the meaning of these terminologies. Therefore, only then you can able to prepare these chemicals. Hydrochloric acid, I think, will be prepared for you by the lab officer. And then all these hydrochloric acid of lower molarity also, I assume, will be prepared. But if it's not prepared prior, maybe you also part in the preparation. It is good that you be part of the preparation. In the long run, you get the hands-on exposure compared to a student where in other universities all been prepared for them. Okay. Then number 8, phenolphthalein. This is the color change will take place in different pH. It's an indicator, and you need to prepare 1% weight over volume, meaning 1 gram in 100 ml of ethanol, not water. And then sodium hydroxide, calcium chloride, magnesium chloride, lead or plumbum acetate all need to prepare as 5% weight over volume. You also have, looks like your foundation of learning chemistry practical comes in handy for this practical in biochemistry, where you need to use the burette for the purpose of titration. Okay. And then reflux condenser, if you do not know how it looks like, I suggest you Google or find a YouTube video on this reflux condenser. Okay, but I will explain a bit on that as we progress through the experiments. Right. Let's start with the saponification, or it's called alkaline hydrolysis. Basically, if you have in the olive oil or palm oil, triacylglyceride to be the majority component, you are trying to cleave it out and release its fatty acid, and also to attach the fatty acid with sodium. Okay, sorry, potassium, because you're using potassium hydroxide today. So, so it's actually creating soap as well. It's a process of soap making by using this saponification process. Okay, so let's go through it step by step. At least can relate to you in theory wise, and then when you go to the lab, it's all will come. You can understand better when you do it hands on. So you given two types of vegetable oil, that is olive oil as well as palm oil. And the way we do it is we have you in groups of 4 or 5 students. Perhaps one group does olive oil while the other does palm oil, and at the end of the session, compare or give the other group results that is been obtained. Therefore, your practical report will have coverage of both palm oil as well as olive oil, and you can do a comparison. So you say you are assigned to olive oil, take 10 ml, and then put in a boiling tube. It's just a look like a test tube but bigger. not a small test tube, but size test tube. And then add what you call potassium hydroxide, and then leave it for 20 minutes in boiling water. But normally we use a menthol heater with beaker of water, and then put this boiling tube that has this content. Okay. Next, we, after boiling for 20 minutes, further boiling with 10 minutes, but before that, add distilled water. But to be careful, it might, boil to a level where when you add it, it fires up, or, shoots out, and therefore you need to be very careful. And after that, it says here cool the mixture to room temperature. And how to go about cooling is actually run through running water, tap water that runs. You can cool it faster by running on tap water. Okay, make sure you don't put the tap water into the boiling tube, then it will be spoiled. Okay, and after which you put one or two drops with a pasture pipette, or plastic pipette, not the micro pipette. This phenolphthalein indicator, and you start the what do you call testing the pH in a rough way by using hydrochloric acid. Yeah, just roughly, the change of color, you stop. You don't have to be worried. It's not pH 7 or whatever. It is to do it roughly, okay, until neutrality is reached. So a rough indicator will do. Okay. And then you take the upper fatty acid layer, not the bottom one. You can see it'll be clearer than the bottom one, as I can recall. And then you can use it for experiment of soap formation, as well as the test for free fatty acid. The problem that I can remember, based on experience for this experiment, is not enough of the upper fatty acid layer will be obtained. So when in the soap formation experiment, they will say prepare 4 liquids with 2 ml. You will see only sufficient to prepare zero point 0.5 ml or lesser for each test tube. But it's okay, we have done it, and it turned out to be full experiment, no doubt. Okay. So assuming you have 4 test tube added with say zero point 0.5, if you get 2 ml each, fantastic. Not zero point 0.5 also will do. And then for the first one, says here saturate with sodium chloride. Um, the monovalent ions, sodium, you will see you can add more, and require a lot of addition, and then only it will be saturated. And also there will be no insoluble salt visible by right lah. Okay, so see whether you can achieve that. And then the second, third, and fourth test tubes, you are to also drop these chemicals, uh, or this salt, or that has valent ions. And then you will see even with a little addition, you will able to observe this some or insoluble salt in theory. Uh, in my experience, sometimes you can't observe it, but try your very best and see that the monovalent formation of soap will not have the uh, scum or insoluble salt, but the valent ion easily will form this scum or insoluble salt. Okay, so that's the what you are expected to achieve. Moving on, we look into test for free fatty acid. the same what do you call this layer, upper fatty acid layer, needed to be sufficient for this as well. Okay, so what you need to do, firstly, prepare the indicator, take 5 ml phenolphthalein solution, then you make it a bit basic by adding NaOH, and the outcome will be it is having a permanent but faint pink solution. If you add too much of the sodium hydroxide, you will see very intense pink color. We will supervise you to make it a bit faint as required by the step. Next, put this 1 ml of the upper fatty acid fraction and roughly add 4 to 5 ml of diethyl ether by not using micropipette, roughly using a measuring cylinder of 10 ml measuring cylinder, or even plastic pipette will do. Okay? And I'm only worried whether you will get 1 ml of the upper fatty acid fraction. If not, again reduce it to 0.5, 0.5 plus 4 ml diethyl still possible. So do the third uh, here also, water, stearic acid, palmitic oleic acid. We also worry whether we have all these fatty acid, pure fatty acid available in the laboratory, because these are very expensive. Maybe we were unable to actually purchase them all, but hopefully got one. If not, just try with water as well as the upper fatty acid fraction. Will still see or compare what the outcome will be, right? And then to this five solution, you take a small, you drop a small drop by using, you want to use a micropipette also can, or just a plastic pipette. You will see once the faint pink color touches the solution, and if it turns out to be acidic, the color will be discharged. If no acidic uh, what you call solution is present, in the palmitic acid or stearic acid, but water will not have, right? The faint pink color will make the whole solution to be pink. The outcome you will supposed to get, and then you supposed to say what has taken place in the saponification process. So that covers the qualitative. We now move on to the quantitative analysis, where three values are to be determined. That is the acid value, saponification number, as well as iodine value. A bit of theory or principle I give very briefly. Acid value, the fatty acid has the carboxylic group, COH, therefore it has acidity. So we're going to determine whether palm oil or olive oil, which one has more acidity. And then saponification number, usually they do it in the factory that makes soap. So it's looking into the connection onto the carboxylic group, the hydrocarbon chain, or the group other than the carboxylic group, whereby if it's longer, the theory is the saponification number will be smaller, and if it's shorter, the saponification number will be bigger. So they use it to determine which oil is good to make soap, and then also batch to batch oil, they needed a particular value of saponification number to be used to make good soap for that. Okay, please find out more about this theory that I am explaining. And then iodine value is about the double bond. Fatty acid or triglyceride have fatty acid which has saturation and unsaturation. So iodine value can find out how much of saturation or unsaturation found in the particular oil. So let's go into the steps itself. A lot of steps here. So let me go through as fast as possible and also clear as possible. The first one is determination of acid value. So you are to take 10 ml of the vegetable oil. Again, group could be in olive oil. Another group could be palm oil. You can put into a flask. It doesn't have to be aluminium flask. It could be just a beaker. But if it is aluminium flask, good enough. Then you add the fat solvent, okay, 50 ml. Put a few drops just to make it as a color indicator for the titration. Put 2 or 3 drops as been indicated, phenolphthalein. Mix it thoroughly, and then you start titration with the burette having potassium hydroxide. So potassium hydroxide by right will not have any color. As you drop into the aluminium flask, you'll get discharge, the pink color. But as you it's not getting discharged, but you'll get pink first and then discharge, and then you will see at a certain end value it will stay on to be pink color. And if you can shake it and the color disappears immediately, then that's not the point. However, as been advised here, if the color stays on or persists for 10 to 20 seconds, you can consider that as the endpoint. Obviously, in chemistry practical, they will say the first run is supposed to be a rough run to know where's the endpoint. Based on our experience, you don't need to do that. One time will do, and make sure that one time is make it count to know the endpoint. Okay, so you record the volume of alkali used, and then you can use it to calculate the acid value. Okay, find out how to calculate the acid value. I'm not giving you the formula. The manual comes without formula, but you can easily Google on what is acid value, and I'm very sure you can calculate the acid value after that by just having the volume of potassium hydroxide achieved. Next is saponification or ester value. So here you just use 3 ml of whichever oil, and then followed by 6 ml of fat solvent. Okay, so 3 ml. So that means 9 ml of the solution. Follow the instruction. Add 50 ml of 10% alcoholic potassium hydroxide. So you mix it thoroughly. For this one, you are to treat it for quite a long time, that is 60 minutes. So you can also watch the video I have managed to pick up for you, how the setup looks like. But it's not only advisable to do it right after the qualitative and also the acid value experiment. So, rather than you do it after you conduct all those experiments, I suggest this is done from the beginning, because at least you already set up the reflux. It can run for 60 minutes, and in that 60 minutes, you can do the earlier experiments. Okay. So, reflux is basically heating the flux underneath, around bottom flux, and that will cause the solution to be evaporated, and this evaporation will be touching a cold surface, the reflux, that has water running in it, and this will cause condensation. And the process of evaporation condensation will be carried on without loss to the outside environment, and this goes on for 60 minutes with the use of heat. Okay, So after 60 minutes, you can cool the mixture to room temperature. Okay, so it looks like it takes a long time, 60 minutes, maybe another 20, 30 minutes cool to room temperature. Only then you can open the device, the reflux, or not, it will shoot out. And then you take the solution once it's cool, you put phenolphthalein. Now you titrate with, in the burette is hydrochloric acid with 2 molar. So from the burette, you drop little by little hydrochloric acid until neutrality, where the color change now will be different compared to the acid value. Okay, please observe the color change, because the color change will decide on the endpoint. And also a word of caution here, careful with this 2 molarity HCl because it's corrosive. And then you record the titer or endpoint volume. And also, just now you put 3 ml of vegetable oil, you need a blank. So they asked to do it again, but this time without adding any vegetable oil. What this means is you add, uh, uh, instead of 3 ml vegetable oil, you use 9 ml of fat solvent. That means 3 ml of fat solvent plus 6 ml of fat solvent, so 9 ml of fat solvent. So you also may want to know what is blank, what is control, find out what is all this meaning. Okay? Moving on, yeah, once you have done the blank will be bigger volume compared to the sample, and therefore you obviously can use this formula to calculate the saponification value. And these two are volume of blank and sample. What is W? W is the weight in gram. So you may ask the question, in the first place you only use ml, volume, where got weight? But if you Google, or the theory says, for oil is understood, ml is directly equivalent to gram. So if you use 3 ml, then it's 3 gram. Okay, so find out that also. So we have completed the second of the three quantitative determination for lipid. Now move on to the final one, that is iodine number, or also known as Haynes method. I hope I'm pronouncing it correctly. This is a bit a lengthy experiment compared to all other experiments, because it's got so many steps. Okay? So let's look into it. We take the oil, either palm oil or olive oil, and we make it into 2%. Okay, 2%. Just now I said weight is equal to volume. Just take 2 gram and then top it up to 100 ml of using chloroform, using volumetric flask. And then triglyceride solution. These are the examples of triglyceride solution. But if my memory serves me right, I don't think we actually did any of this, again due to unavailability of this triglyceride. Okay, it's okay. We still able to achieve using the palm oil as well as the olive oil, and it is enough to compare in terms of unsaturation as well as saturation. Okay, iodine monochloride. If the lab officer did not prepare, then you have to prepare yourself. Right. The rest of it has been indicated. All this, please look into preparation. Again, this one is another titration method, therefore you need to use the burette. One caution is, I'm not sure whether 50 ml burette is sufficient, but I don't think we have anything bigger than 50 ml, because the endpoint, unlike the previous method, the endpoint goes more than 50 ml. So you might have to top it up after 50 ml finish, and then only you get the endpoint something like 70 or 80. I can't remember. Okay, so only that I would like to give you some what do you call idea beforehand. Okay. Right. Take the pipette of 10 ml and then put the 2% vegetable oil. Doesn't have to be a stoppered bottle. I think we have modified using different kind of bottle, but screw cap we use already, because stoppered bottle is a old apparatus. Add iodine chloride, mix thoroughly, and then screw cap it, and then leave it in dark for 1 hour. Again, a bit of preparation prior hand. You may want to have, say, 4 or 5 members in a group. Maybe 2 person can do this from the beginning, not assigned to do it, so you save time, because it requires to be left for 1 hour. Okay. So, also been told, prepare a blank, that is, instead of the oil or triglyceride, you use 10 ml of chloroform, because the equation requires the volume of blank. Therefore, you must do this. You cannot just omit this, determining for the blank. Okay. So, you must leave the oil in the dark for 1 hour, but the blank, not necessarily you must leave it in the dark. You can just prepare right before you do the experiment, because the blank does not have the oil, so no reaction likely to take place. But if you want to be consistent, you can prepare both and left for 1 hour. So after 1 hour, you add distilled water, mix it thoroughly. You start by adding 100 ml of potassium iodide solution. There will be a reaction taking place. Most probably, the double bonds are replaced with iodine. Okay. And then, when the solution turns pale straw solution, okay, I used to have the color pale straw here. Not sure why it went missing, but please Google what's the pale straw color looks like. And when after adding a lot, if I recall, of the sodium thiosulfate, which is now found in the burette, quite a lot of volume you have to add. As I said before, even exceed 50 ml. Only then you will see the pale straw color coming about, and that's where you add the starch solution, and then you continue titration with sodium thiosulfate, and you do it until the blue color disappears. It's quite fast, it will disappear, so be careful. And if you go overboard, added more than supposed to of sodium thiosulfate, you will be not happy, because you might have to repeat, and that will take a long time to repeat. Okay, so make sure you also shake thoroughly, and then that all the iodine is removed. So shaking is important for this purpose. And finally, you would have two values for blank, as well as the test or the sample with the oil, blank without the oil. And this volume of thiosulfate you can then use to do the calculation. So is here the amount of triglyceride is zero point 0.2 gram, and 1 liter of zero point 0.1 molar iodine contains a bit of theory. You may just ignore that. Don't worry. You can just use this equation, which all this stands for 6.35. So put in the blank volume of for sodium thiosulfate used for the blank, from the titration, and also for the oil, how much of sodium thiosulfate you use to titre the oil preparation, and do the summing, then you get the iodine number. Okay, so that's all the experiments explained in thoroughly. Now we go into the end of the briefing. You need to calculate the all the three values: acid values, saponification, and iodine values, and then compare them. Hopefully, you can compare with palm oil and the olive oil. Okay, and then say which one has better value. And what does it mean, high acid value? What does that mean, high saponification value? What does that mean, high iodine value? What does that mean? Okay, so that's the significance of these values. Okay, that's it. I have completed the briefing. It's a bit long, around 40 minutes or so, but please view it before you come to the lab. We save a lot of time. In fact, we save around 40 minutes of my briefing if we are doing this practical in 3 hours. Thank you.